In this video, I will explain analyzing nominal variables using Python. A nominal variable represents distinct categories or labels without any inherent order or ranking among them. The values are purely qualitative. In addition, I will also discuss how to import data into Visual Studio Code. I will start with Visual Studio Code. Click here and open folder. I have made a folder for Python and this folder is named demo and it has only data file which is Python sales data, nothing else. Click on open folder and then here I will create a new file where I will be entering all my codes. So click on this one and let's call it demo and then IPYNB, which stands for Interactive Python Notebook. This is the file where we will be working and this file has been stored in the same folder. The new file that I created, it is stored here. Initially there was only our data file, but now our Python file is also stored here. In Visual Studio Code, our starting command is always this: pip install pandas, seaborn, matplotlib and numpy. I will run this command and then importing these libraries, import matplotlib.pyplot as plt, import seaborn as sns, import pandas as pd. Some of them will not be used, but I usually import all of them, so in case if we ever need to use them, they will be there. Then I will run them. Next step is to import data from CSV file into Visual Studio Code, and for this one I will create a file. My file is equal to, you can use any name instead of my file, pd.read_csv, and then it will give us suggestions. Now I know in my case it is users, and when I enter / then it gives me two options. I know my data is here and then again / and then it again gives me some suggestion. I know my folder which I set up earlier is on desktop and then again / and then I can see here this is the folder name of the folder that I created / and this is CSV file. So this command specifies the full path to import that file. I will run this one. I want to discuss another way of importing data using a code which is shorter and there are less chances of making an error. So this is our traditional way. I will not be using it, so I can delete this one because I do not want to use this one. So this command is shorter. New file pd.read_csvr and then name of the file, and you can see the difference is that over here we are not specifying the full path. So I'm not even using here / etc. I am only specifying here the name of the file, and this file is in the same folder that we set up earlier. Now let's see if our data has been successfully imported or not. I will use this one, new file.head, and if I run this command it shows us top rows. If I want to see bottom rows, then I'll be using this command, new file.tail and then parentheses, and if I run this command that shows us bottom rows. In this data, this is our nominal variable, product category. Sales amount is quantitative variable, quantity sold, they are all number, discount is number, but product category is a nominal variable. In this product category column we have different items such as home goods, toys, clothing, electronics, and in the first step we want to analyze sales amount of each separately. So we want to analyze sales of home goods separately and then toys separately and clothing separately and electronics separately. So for this purpose I'll be using this command, average sales. For example, if I want to calculate average of each, new file, that's the name of the file which is containing our data, and then group by, and then product category, that's the name of the variable, and then sales amount against which we want to compare it, and then in the last step we have mean and then parentheses open and close, which means we want to calculate average. So if I run this command it gives us average of individual items in product category. So this is average for books, average for clothing, electronics, home goods and toys. We can use the same code, but instead of mean we can also use here sum or total. So for example, if we want to calculate total sum of books, clothing, electronics, then I'll be using the same command. The only difference is that instead of mean, I'm using here sum. and I will also change the name. And if I run this one, it gives us that for books, total sales was this, clothing this much, electronics, home good, and toys. We can also calculate descriptives, and for that again the command remains the same, only this part changes, and then also the name will also be changed. And if I run this command, it gives us descriptive statistics for individual items. For books, this is count. We have 26 values. Their mean is this one, their standard deviation, minimum, first quartile, second quartile, third quartile, and maximum for clothing, electronics, home good, and toys. We get descriptive statistics for each item individually. Next, we want to make a bar plot of this nominal variable, and bar plot is particularly suitable to nominal variables. And for this one, I'm using this command, product categories, which means defining this variable. So this is our file, new file, and product categories is equal to new file and product category. And this is the variable that I define because I want to use it. Next, we want to count it. So product categories, once we have defined it, dot value underscore counts, and then plot kind bar. If I run this command, it makes this type of bar plot that gives us frequency of books, clothing, toys, electronics, and home goods. You can also add here more information such as title, x-axis, and y-axis. Then next, I will make a pie chart. Pie chart is also suitable for categorical or nominal variables. And for this one, I'm using this command. Variable count is equal to product categories, and we have already defined product categories in the upper command, and then value counts. This part is gonna count all of them. And then plot figure, fig size is equal to 10,8. You can also make it 8 by 8. And then plot pie, which is the core command for making pie chart. Variable count and labels is also variable count, index. And then we have automatic %. And in the next step, plot show. If I run this command, that gives us this pie chart, which shows frequency of individual items, clothing, toys, books, home goods, and electronics. In the last step, I want to make a percentage bar plot. A percentage bar plot is very much similar to bar plot. The only difference is that we'll be using here percentage. So for this one, I'll be using this command, plot.figure, fig size 10 by 6. Percentage is equal to product category. This is the variable we have already defined. And then value underscore counts. Normalize is equal to true multiplied by 100, and percentage plot kind bar, and then show it. And if I run this command, it gives us this one. This bar plot is similar to the bar plot we made earlier. The only thing is that it shows percentage. So this is percentage for books, clothing, toys, electronics, and home goods. Last step is how to export sum of results to a CSV file. So for example, we have descriptives here. Here we have descriptive statistics. If you want to export these results to a CSV file, I'll be using this command. Now before I execute this command, let me show you our original folder. This is our original folder that I set up in the start. It has only two files. The first one is our data file, and the other one is Python file, no third file. If I run this command, it will create a CSV file in that folder for descriptive statistics. Let's go back to our original folder and see what happened there. So this is our folder, and as you can see here, a new file is created, descriptives CSV. If I click this file, all descriptives appear here. So these are individual items and these are statistics.